yesterday. All my troubles seem so far away. Now everybody stands 6 feet away. Oh, I believe in yesterday. Suddenly things just aren't the way they used to be. Now I turn all my sheets in digitally. Oh, I believe. I gotta get to work. All right, actually, this is my work. Back to probability statistics. So, you should have this sheet in pink already, but there's multiple copies everywhere, especially digitally. This is a little bit of a recap from last time with a little something new added in. It's some notation. It might look a little confusing at first, but I'll teach you a way to do it that we already know how to do instead of doing all this fancy stuff. But I still want to talk about it because it's good to understand the notation. So this is permutations. At the top, of course, we have the definition. Permutation is an arrangement of objects or things in some specific order. So order matters. So we're going to highlight this stuff because normally my stuff is in bold, but this one's not. So we'll highlight it. For example, if I have 5 horses in a race, we'll see if we have races this year. How many possible ways can they finish the race? And another example is how many ways can 10 students be arranged in a line. So it doesn't really matter what it is I'm arranging, but it's in a certain order. There's another thing in here. We don't use it much, but you will in your future. Factorials. It's not a super excited n. This is not n. It is n factorial. And this is the number n, and this is 1 less than n, 2 less than n. So it's basically saying you take the number you have and you count it down, and you multiply all those numbers together. And it's just some information right now. We didn't use it yet. We're going to use it in a minute. So we got our permutation notation, which can be confusing. So pay attention. Paga la atención. The permutation of this many objects, n objects, taken that many at a time, because sometimes I don't want them all, but this one is. If I take all my objects, n at a time, I get n factorial, meaning I multiply everything counting down. You're saying right now you're really confused. Yes, I'm just giving you information. Trust me, you will get this. So, for example, if I have 14 boys, it's important, I'll underline it, on the baseball team, the coach must establish a batting order for the players at each game. In how many ways can the coach arrange, so order matters, so it's permutation, the first 4 batters? So if I'm going to use this new notation I'm trying to teach you, then you would write, I have 14 total batters. I'm going to take the permutation, because order matters, of those 14 batters, but I'm only going to do 4 at a time. So one more time, this says the permutation of 14 batters taken 4 at a time. Now I can teach you the formula for this, but I would rather just show you how it relates to what we were already doing. Remember we did counting principle? And I need to choose 4 batters. So I'm going to put 4 spaces there. How many choices do I have for the first batter? I have 14 people on the team. Once somebody is chosen to bat first, that used to be my spot, then you would choose somebody else. Now there are 13 people left to choose for the second spot, and then 12 for the third, and 11 for the fourth spot. That would make a total of 24,024 different arrangements of batters 1, 2, 3, and 4. Okay? And then there's this other thing. Let's say we have some duplicates. I mean, these are all 14 different people. Let's say there's some duplicates in the order. Like let's say I rearrange the word baby. So you would do n factorial and then divide it by the repeated stuff factorial. So if I wanted to see how many different 4-letter words, if they're different, the order matters. 4-letter words can be made from this word baby, you do not want to sit there and rearrange this all day. Let's do the math shortcut. So you've got 4 choices for the first word, the first letter, 3 choices for the second letter, 2 for the third letter, and 1 left for the last letter. And the shortcut for 4, 3, 2, 1 is 4 factorial. Now here's the thing. If you rearrange, let's say this B and that B, do you get a new word? No. So you don't want to count all those extras because it doesn't make a new word. So you're going to divide off the things that are repeated. There is 2 B's. So I'm going to divide by 2 factorial. There's nothing else repeated. And again, factorial means to count down multiplying. And the answer would be 12. Okay? Great thing about a video is you just go ahead and replay what you need to replay. So let's just practice the notation, which I relate to counting principle. If I'm using the calculator right now, it's really only for multiplying. So if I want the permutation of 6 things taken 3 at a time, I'm choosing 3 things. And the number of options I have for the first spot are 6. Once that is chosen, then I have 5, and then I have 4. So there are 120 different ways that I can choose 6 things 3 at a time. All right? Let's try that one more time. The permutation of 10 things taken 2 at a time. So I'm choosing 2 things, and out of that I have 10 options for the first thing, 9 for the second. So there are 90 ways to do this. Now, if you're curious, I'll show you how to do this without counting principle on the calculator. So you have to think, what chapter am I in right now? I'm in probability. That is going to help you understand what to do on the calculator. So I'm going to type in the 25 first. 25. And then I'm going to press the probability button. You see the NPR? That's the permutation button, so I'm going to press enter. And then I'm going to take those 25 things 2 at a time, so I'll press 2. The permutation of 25 things taken 2 at a time is 600. So I'll write that down for some notes. This is the PRB button because we're doing probability. And that comes out to 600. One more time, maybe off on the side here. The NPR button is found from pressing PRB. You press this number, then the button, and then the last number, and then enter. Okay, so what I want you to do right now is pause the video and try these 4 through 8 on your own. Okay, here's your answers for those next 4. I'm going to try one more, you're going to try one more, and then we're going to flip this thing over. So on the bottom, tell how many possible winning orders there are for a horse race where 3 horses finish in the winning position, for example. So you have to interpret that. So does order matter in a race? It certainly does. You guessed the first horse right, you win more money. So order matters, so I'm going to do the permutation. It is the permutation of this many horses, but I only care about the first 3. So I'm going to take that 3 at a time. The permutation of 7 things taken 3 at a time, you can use the buttons on the calculator, or you can start with 7, put 3 spaces, and count down, which is counting principle, very similar to counting principle. There's 210 different ways that can happen. Okay, go ahead and try the next one on your own. Pause the video. Okay, should have got 504. Okay, let's try number 10 together on the next side. A class of 31 students, so that sounds like a total, elects 4 people to office. Would you have noticed the number 4 if I didn't already underline it for you? Think about that. Vice president, secretary, we're picking a president, a vice president, a secretary, and a treasurer. So that's 4 things. In how many possible ways can 4 people be elected from the class? So you ask yourself, does order matter? Well, it does, because I'm specifically picking different places. Not everybody's the same. I'm getting a president, a vice president, a secretary and a treasurer. So that's kind of like order mattering. So I'm going to do the permutation of, what's my total? 31. And how many people am I picking? Okay, so if I'm not using these buttons on the calculator, that's PRB, you would press 31, then PRB, the B, the NPR, kind of like the news, the number I choose, or you're just going to do 4 spaces, because I've got 4 spots: president, vice president, secretary, treasurer. So I got 31 people who could have been president. Once somebody is chosen, I have less. And I could draw a tree diagram. They branch out and they multiply, or I can just do multiplication. That would make 755,160 different ways that can happen. Okay? Let's get back to some regular numbers. Digits, for example. A lottery ticket contains 4-digit numbers. How many possible 4-digit numbers are there when a digit may appear only once in the number? So, what am I choosing? Choosing 4 numbers. Trying to win the lotto. And digits. Digits are numbers. How many numbers are there? When we talk about single digits. Digits, the lowest number is 0. And it goes up to 9, right? 10's not a digit. 10 is 2 digits. That's a 1 and a 0. It's not a digit. So these are the single digits. You have to think, how many numbers is that? The most common mistake is people say that it is 9. That is not 9 numbers. 1 through 9 is 9 numbers. When you include 0, that makes 10 digits. So I can only use a number once, so there are 10 digits I can use for my first number. And then since I used one of those numbers, I have one less in all of the next spots, which comes out to 5,040 different lotto numbers. Things are different, of course, if you can repeat or have something appear more than once. I'm still going to pick a 4-digit number. There's 0 through 9, which is 10 digits. And if I can repeat it, there are still 10 digits the other times. And if you remember from exponent rules, let's just review that for a second. The number of times you repeatedly multiply the base is the exponent. I repeatedly multiplied this base 4 times. That's why the exponent is 4. And that is 10,000. Okay? All right. Why don't you try 12 and 13 on your own and then unpause it. I don't know if you noticed, but when you did this one and you put it in the calculator, you get this strange stuff over here. In 8th grade, you're going to go over this more. This is called scientific notation. This is, see how this was 10 to the 4. This is what 10 to the 4 looked like. So 10 to the 40 obviously is a lot bigger. So this number is so huge that the calculator wrote it in scientific notation. I don't really want you to worry about that, but it's something to note so you don't get too freaked out. The calculator still works. That's just, it's a number that's so big that they had to have a shortcut for it. So the next one, we didn't do any of these word examples, so let's check a few of those out and try some on your own. How many different 6-letter arrangements can be formed using these letters? So 1, 2, 3, 4, 5, 6. It's 6 letters. I was just double checking. So we do our total in the numerator, the n factorial, and we divide off the repeats. So there's 6 letters. And what's repeated? There are 3 T's. So I'm going to divide off those, because if I put a T in another spot where a T is, it doesn't change the word. There are no repeated A's, but there are 2 repeated O's. So I have to do that. And I kind of like to do some of this stuff by hand because there is just something so gratifying about dividing off. And remember, factorial means counting down. So I'm just counting down, counting down. There's 2 times 1. There's 3. 2 goes into 4. And 6 times 5 is 30, times 2 is 60. Now, you really should know how to do that, but Mrs. Roberts always says, why don't you go to your calculator and have the calculator do the work for you and not worry about all that other stuff. Okay, I'll do one more. We'll do system. System has 6 letters, Is anything repeated? Oh, there's two S's, so that is the only thing I divide off. Now you need to remember, this is factorial, so it's kind of like order of operations. Kind of like factorials, like parentheses. You have to do that first. You cannot do 6 divided by 2 is 3. This is not 6 divided by 2. This is 6 factorial, which is a completely larger number, divided by 2 factorial. So this is not 6 divided by 2. It's not, the answer is not 3, it's 360. So please be careful, okay? So pause the video, try these 2 examples and the bottom one. Okay, so B I got 720, D I got 120, and on the bottom I got another 720. You know, I didn't go over how to do factorial in the calculator. Some of you might want to know how to do that shortcut. You have to remember, again, we are doing probability. So it is the probability button. So if I want to do 6 factorial, I'll tell the calculator 6 first. I'll press probability because that's the unit we're doing. And you'll see factorial button is number 3. You see I skipped over number 2, which was NCR. That's combinations where the order doesn't matter. And we're not going to do that right now. So there we go. And I want to do one more from the homework before I say goodbye. So you really should be writing your notes. Notes are important. And I want you to make sure you keep your notes. Do not turn in your packets of homework. You need to use them to help you with your upcoming graded assignments, aka tests. So if you want a paper copy, you can certainly get these things from the school. But actually, you know, everybody has this. If you look at this, you could tell I photocopied it from the workbook. The workbook, that orange math book I gave you, has this page on it. So if I were you, I would go get that workbook, turn to page 769, and do my homework right in the workbook, which you are not turning in to me physically. Okay, so this is the first page of the homework. You should always show all your work, like filling in the blanks or what calculator buttons you pressed. You should never have a page that just has answers because it's not going to help you. There's an answer key online that you can check. I've already done that. What I want from you are the steps and the work and the understanding. So this was the first page of the homework, which is in your math textbook. Just do it right in there. And then on the back is the problem I wanted to go over. Remember, if you see problems that say persevere, persevere means to keep at something that's difficult. So remember, those are going to be harder questions. And it kind of helps sometimes just to be aware of what's easy to do and what's harder to do, because it kind of helps you to be cautious and you make sure you show more steps. Okay, now I like number 10 because you have to read carefully. One of the hardest parts of math isn't the math, it's the reading. So let's see if you key in on some of the key stuff in number 10. Howard Middle School assigns a 4-digit identification number to each student. The important thing here is it's 4 digits. 4 digits. 1, 2, 3, 4. I'm going to choose 4 digits. The number is made from the digits 1, 2, 3, 4. So not 0 through 9. These are my only choices, 1, 2, 3, and 4. So that's 4 choices. No digit. So, no digit is repeated. If this is assigned randomly, what is the probability, the chance that an ID number will end with a 3? So, that is super important. I need it to end in a 3. So here's my digit number. I need it to end in a 3. And to not confuse you, I'm going to write the word 3. Because remember, these are my spots for choices. Right here, I don't have choices. I have a choice. It's supposed to be 3. How many of these numbers are 3? 1. There is 1 3 in this list. What's going to be confusing is you're going to hear the number 3 and then you're going to want to write the number 3. But a 3 is 1 choice. So now that the 3 has chosen last, I like to take care of my problems first. So I took care of that problem. Now I'm going to go back to my first digit. I have 1, 2, 3 numbers left to choose for the first digit. Now there is 1 less number than before, so now there's only 2 here and only 1 here. Now that might look weird to you, but it's totally right. This is ending with a 3. That means there's only 6 different combos that will end in a 3. Now, did it ask me for the number of ways? Let's see what I circled. I circled what's the probability. Probability is a fraction. Probability is a decimal. Probability is a percent. On the side, you see it's the number of ways to get what I want out of the total. This is what I want, so there's 6 ways. Now, how many total ways were there? I don't know, I didn't do that. So I'm going to go up here and do my total ways. If I don't have to choose a 3 last, how many ways can I do this? So I have how many choices for the first number if it's anything? Well, there's 4, but I'm still not going to repeat it. So that means there's still 1 less here. And this is different because I didn't have to choose a 3 last, so it gives me more choices. Matter of fact, the number of choices I have are 24. And a lot of times things get reduced, especially if it's a multiple choice question. I think this tells a better story than the reduced version, but be aware of that. Okay, finish your homework. I'll see you in Google Meets.